Okay, so here in constant volume gas thermometer, you can use different gases. Okay, gases can be different. So when you use different gases, the problem is that this A and B will be different. Temperature is proportional to the pressure, but for different gases A and B are different. So let us plot this pressure and temperature in a graph. So you have 2 points 1 and 2. Okay, so that means when you take a pressure corresponding to this pressure, you will measure the temperature 1, and corresponding this 2, you will measure the temperature and also the pressure. Okay, so you can write T1 is equal to A plus BP1. Okay, then T2 is equal to A plus BP2. Okay, so corresponding to state 1 and state 2, that is T1 is equal to A plus BP1, T2 is equal to A plus BP2. So you can draw a line, okay, through these lines. It will meet here. So this is for gas A. Okay, this is for gas A. Now you can take another 2 points, measure the pressure and temperature for another gas B. Okay, this is for another gas B. So now it will have the intercept here. Okay, and it will have a different slope because this A and B will be different for another gas. So another gas, if you take, it will be like this. It will have a different points. Uh, so again, it will have an intercept here. Now, see, if you extend these lines, okay, if you extend these lines, that means when the pressure is zero. So when the pressure is zero, it will all meet at a common point. This will all meet at a common point. And this is minus 273.15. Its value is minus 273.15. Okay, and this point is called, that means the pressure of the gas is reduced to zero. Practically that is impossible to achieve, but if you reduce that to zero, it will, these all lines will meet at a common point, that is called minus 273.15, and this is called the absolute zero. This is called the absolute zero temperature. Okay, this is called the absolute zero temperature. Now if you take these, so another scale is introduced here, that is the Kelvin scale. Okay, you have discussed already Celsius scale and Fahrenheit scale. So in Celsius scale, we will start from this absolute zero. That is, see, in Celsius scale, you have minus 273 degrees Celsius, 273.15. This was the absolute zero. For Fahrenheit, it will be minus 459 degree Fahrenheit. See, this absolute zero is represented as 0 Kelvin in Kelvin scale. Okay, that means Kelvin scale is equal to Celsius scale plus 273. Okay, this is the difference. Okay, so the boiling point here, Celsius scale, it is 100 degrees Celsius. So plus 273 is equal to 373.5. The correct value is 273.15, but for usually we take only 273. Okay, so water boils at 370. So this is the new scale that we use, that is the absolute scale or the Kelvin scale. Here the absolute temperature is 0 Kelvin. This is the minimum temperature that you cannot go below absolute. So it is also impossible to get 0 Kelvin also. At 0 Kelvin, the pressure of the gas 0, that means all the molecular motion will come down to, will become 0. So that is the Kelvin scale. This is the Kelvin scale. So you have the absolute 0, that is the 0 Kelvin. Absolute 0 is the 0 Kelvin. And now let us make a comparison between Celsius and Kelvin scale. So the formula for Kelvin scale temperature is equal to T is equal to T in degree Celsius plus 273.15. Usually we take only 273, but the correct formula is 273.15 Kelvin.